Okay, it again. Yeah, good. So what will be m dash of x? Derivative of x cube, which is 3x square plus derivative of 10x is 10. So you can see 3x square plus 10. X square, a quantity which is squared, will always be positive. And if this is always positive, we are multiplying with 3 and adding 10. That means f dash of x will always be greater than 0 for all x belongs to real numbers. That means if f dash of x is greater than 0, implies the function f is an increasing function. Got it? Now, let's see here. The second question says, test whether the function is increasing or decreasing. So, like, we have to check whether increasing or decreasing. Same thing we'll do. What we'll do? We'll check f dash of x. So, f dash of x equal to 3x square plus 12x plus 12. I hope you got it. We can take 3 common from here. So if I take 3 common, I will get x square plus 4x plus 4. And what is this? If we try to factorize it, you will see that it is x plus 2 the whole square. That means it is a squared quantity. So if it is a squared quantity, this is always positive, and 3 is a positive number. So that means f dash of x is always greater than or equal to 0. If x is minus 2, then it will be equal to 0. For all x belongs to R. That means for all x belongs to real numbers. And that means f is increasing function. Why it is increasing function? Because f dash is greater than 0. So simple. Now, these are the questions which are type 1. One more type questions are asked, that are these. Find the values of x for which the function increases and decreases. These are the main type of questions that are asked. So what we can do here, let's see. We have two cases to find the increasing as well as to find the decreasing. So we can actually find f dash of x. Let's find f dash of x. F dash of x will be 3x square plus 24x plus 36. So what does this mean? This means that if I go for case 1, that means f dash of x should be greater than x 0. Okay, so if you are giving theory paper, then we have to actually ideally consider cases like case 1, case 2. But since if we're doing MCQ paper, then we can use the best method for inequality, which is the wavy curve method. I hope you remember wavy curve method. What does wavy curve method say? Let's see. Wavy curve method says draw a number line, plot the critical points which are -6, and here it is -2, and draw a wave starting from positive side. So if I draw this wave, the positive areas means above the x-axis, these one. So that means my answer are the positive areas. That means x will belong to -infinity to -6. Union 2 to infinity. Why I used square bracket on 2 and -6? Because it was equality here. It was equality. Therefore, there is a square bracket here and here. Got it? So, and if someone asks me the second type is decreasing, means f dash of x is less than or equal to 0. So same, these all steps will be the same. We just will get x plus 6 into x plus 2 less than equals to 0. So again we'll do the same thing. Wavy curve -6, -2, draw a wave, and this time we are looking for less than 0 means negative side, means below the axis. So this will be negative. So that means, oh, sorry, negative. So that means here x will belong to, sorry, -6 to -2. Again, why there is square bracket on -6, -2? Because here we have an equality. Chalo. Now, if it is clear, then we'll move on to the next concept. The increasing decreasing function parts are very simple. You can easily get all the answers, and these are the such questions which can be asked. So let's move on to the last part. Last part means the fourth and the final application, which is maxima and minima. So what is maxima and minima? Let us check. Maxima means the maximum value of the function. Minima means the minimum value of the function. So when we are talking about maxima and minima, basically we are talking about maximum and minimum value of the function. So what does maxima means? That is only a definition. It is that maxima at point x equal to c if the value of function at x equal to is greater than the other values. And minima means it is less than. Now, let us see from graph how we can see. And before that, a simple technical terms you need to understand. Suppose f dash is equal to 0, then x equal to c, that point is called the turning point or the stationary point. That means if somewhere a derivative of the function becomes 0, derivative of the function becomes 0, that means that the tangent drawn at the point is parallel to x-axis. What does that mean? That means the tangent, slope of the tangent is 0. So if such a point exists, then those points are called turning points or stationary points. And at those turning or stationary points, there can be either minima or maxima. Got it? So let's understand it with graph. It will be more clear. So here, as you can see this graph, this is the point where the tangent is drawn. That is the line L2. And it is parallel to x-axis. Means it is slope, it has slope 0. So that means the slope of this tangent is 0. In this point, which is point C, is a stationary point. Now, how do we know it is a maximum or minimum point? Right? We can easily look out from the graph. So from the graph, it is clear that it is a maximum point. But by the second derivative test, we can say that it is a maximum or minimum point. What we need to do here, we just need to check f double dash. That means double derivative. We talked about successive differentiation, if you remember, second derivative, third derivative. So here, the double derivative at x equal to c should be less than 0. And if this condition satisfied, that means we have a maxima. That is the maximum value. And same is for minima. Minima mein also we will get the slope of tangent as 0. But this point will be minima if f double dash at that point is less than 0. Less than 0 means, sorry, greater than 0. Greater than 0 means it is positive. Got it? So just we need to check two things. First, we need to find the stationary points. How do we get stationary points? By uh, equating f dash of x equal to 0. So when we get those stationary points, then what we can say? We can now check the double derivative. If double derivative positive, minima, negative, maxima. It is just ulta. Greater than 0, so minima. Less than 0, so maxima. Chalo, let's start. Here, it is a graph for explaining what is the double derivative. Now, many a times, double derivative test fails. There will be cases where, suppose say, f double dash of c is not greater than or less than 0. It is equal to 0. It is equal to 0. So in such cases, what do we do? If this implies double derivative test fails. And if double derivative test fails, what we can do? We use a single derivative. We use single derivative test. So what is single derivative test? Single derivative test says that if suppose we have a maxima, then before the maxima, the tangent slope will be positive because the inclination is acute. And what is the slope of tangent? dy over dx will be positive. And after the maxima, the tangent will be like this. Means the tangent slope will be negative because the inclination is negative. That means dy over dx will be less than 0. So you can see here clearly that before and after the stationary point, this is called stationary point, the derivative changes its sign. Like for maxima, it was greater than 0 and then it became less than 0. So dy by dx went from positive to negative. And if such cases happen, we should always remember this diagram. Positive means slope positive, negative means slope negative. And if dy by dx changes its sign, that means from positive to negative. That means this is a point of maxima. This is a point of maxima. Let's say suppose we have minima. So what does this minima say? Before the stationary point, the tangent is like this. Means the inclination is obtuse. That means dy over dx is less than 0. And after the stationary point, tangent is like this. Means inclination is acute. That means dy over dx is greater than 0. So what is the sign change for dy by dx? If before the stationary point, dy by dx is negative and after that it becomes positive. So my curve will negative and after that positive. So this point will be the point of minima. This point will be the point of minima. You just need to remember the diagram. It's very simple. For maxima, it is positive to negative. For minima, it is negative to positive. So this is the first derivative test. From how we can see if second derivative fails, we'll use the sign change for the first derivative. So now we can clearly do questions. We have again two methods, the second derivative test, the first derivative test. If the question in the question it is not mentioned, then we can use any method. Sorry, but if it is mentioned specifically to do by second derivative test, then we have to do by that. Got it? The first and second derivative test. I hope it is clear. Now, I am very thirsty, so I'll drink some water. Till now, you just see what we have revised. Just I'll come in 30 to 40 seconds. Okay, guys. Chalo. I'm back. Yeah. Let's start. I hope you are clear. Second derivative test. F double dash greater than 0, minima. F double dash less than 0, maxima. First derivative test, dy by dx changes from positive to negative, maxima. From negative to positive, minima. Let's do the questions. So here they are asking, find the local maximum and local minimum. So what is meant by local maximum and local minimum? Same, maxima and minima. So if we use suppose second derivative test, okay, second derivative test, we have to first find the stationary points. Means we have to find values of x when f dash of x equal to 0. So what will be f dash of x from here? What will be f dash of x from here? It will be 3x square minus 6x minus 24 equals to 0. We can divide by 3. So x square minus 2x minus 3, 8 I guess, equals to 0. Right? So what are the factors? 8 we want. 4 to the 8. Minus 4 plus 2. So x minus 4 into x plus 2 equals to 0. That means x equal to minus 2 and it is 4. So these are the stationary points. Now to check whether there is maxima or minima at this point, what we'll do? To check whether there is maxima or minima at this point, what we'll do? We'll check double derivative. So let's find f double dash of x. Right? This was f dash of x. So f double dash of x will differentiate it again. So it will be 6x. Am I right? Yes. Minus 6. Right? Now, let's say we substitute minus 2. So if I put minus 2, I will get 6 into minus 2 minus 6, which is minus 12 minus 6. I am not at all interested in the answer. I am just interested whether it is positive or negative. And if it is negative, that means ulta, negative to maxima. So x equal to minus 2 is a point of maximum value. And we have to find the value. Value means the function value. So that means we will find f of minus 2. F of minus 2, substitute here just minus 2. So minus 2 cube minus 3 into minus 2 square minus 24 into minus 2 plus 5. Whatever value we'll get, that will be answer. I am not at all interested in calculating that. I give it to you. So let's check if 4 will be a point of maximum minima. Don't use this logic. Ki, if it is maxima at 2, minus 2, then at 4 it will be minima. No, no. There can be 2 points of maxima. Don't misunderstand, please. There can be 2 points of maxima. So please don't misunderstand this. So again, we have to obviously check with double derivative. So this was a double derivative. Now we'll substitute 4. If I substitute 4, I'll get 6 into 4 minus 6, which is 24 minus 6, which is positive. And if it is positive, to ulta, it will be point of minima. That means x equal to 4 is point of minima. And what is the minimum value? It will be f of 4, which is 4 cube minus 3 into 4 square minus 24 into 4 plus 5. So whatever value it comes, that will be my answer. Achha, we can calculate this. 4 for the 16 4s are 64 minus 16 3s are 48, I guess. 24 4s are 96 plus 5. I guess we are getting negative value, right? है ना? 48, 58, 10 and 60 minus 80. So minus 75 we are getting. Right? Chal. I hope it is clear. We can look at more example. Now, this is a very, very, very simple example, but it is an actual example. Let me tell you what are actual examples, real life applications, you can say. So here, I would like you all to read the question first so that you can understand. Please read the question first. Are you done? If you are done reading the question, then let me tell you how we can use maxima and minima for getting such answers. Got it? So that is basically, see, we have done rate change, right? Rate change may we know all the spheres, like we should know, I mentioned, we should know the mensuration formula from 10th standard. That means mensuration formula for 10th standard, that means the area, surface area, curved surface area, total surface area, and volume of various figures. Square, ho gaya, rectangle, sphere, cylinder, and all. So here, let us do this question. A wire of length 36 meters is bent in the form of a rectangle. Means there is a wire of 36 meters and we have bent it in a rectangle. That means the total length of the rectangle, or we can say total perimeter of the rectangle will be 36 meters. Find the dimensions if the area of the rectangle is maximum. What we have to do? We have to find the dimensions. So let's first define the dimensions. Let the length be x and the breadth be y. So what will be the area? Area will be x into y. Equation number 1. So we have to maximize this area. And if you remember the maximum and minimum, how we get the maxima and minima, we need to differentiate the function. Now, looking at a equals to xy, we cannot differentiate a function because it is a function of two variables, the length and the breadth. So if I increase length, area will increase. If I increase breadth, area will increase. That means it is a function of two variables. So what we need to do, we need to make area a function of one variable. So let's say, how do we make? By the given condition, 36 meter. So what is the perimeter? Perimeter, it is given, it is 36. So do you know perimeter of rectangle? Perimeter of rectangle, rectangle means sum of the all the sides, right? So what is the perimeter of rectangle? Let's see. Perimeter of rectangle is 2 times length plus breadth equals to 36. So here from here I will get x plus y equals to 36. That means y equals to 36 minus x. So if I substitute equation 2 in 1, if I substitute 2 in 1, so I will get area, which is x into 36 minus x. So that means now my area is a function of x. So I can write f of x equals to, we can open the bracket, 36x minus x square. From here, now we start the last question how we approach this one. We are given f of x. Here in word problems, we just have to make f of x from the given English, from the given question. That means in English it is given, we convert it into mathematics. I like to visualize it like that. They give question in English, we convert into mathematics. So let us now, we got f of x. So what will do for maximum minima? We'll do f dash of x. So here f dash of x will be equal to 36 minus 2x. Now to get critical points, we have to equate it to 0. So that will give me 36 equals to 2x. That means x equals to 18. X equals to 18. So this is my maximum or minimum point or stationary point, we can say. I don't know whether this is the maximum point or minimum point. So what we'll do, we'll find f double dash of x. Now f double dash of x means we have to differentiate this. So I guess we'll only get 0 minus 2, which is minus 2. So if I find f double dash of 18, then I'll get minus 2. There is no x to substitute, which is less than 0. That means x equals to 18 is less than 0 means ulta is a point of maxima. X equal to 18 is a point of maxima. So that means f of x, that means area will be maximum when x equals to 18. And from equation number 2, we'll also get y equals to 18. So what are the dimensions? Dimensions is length is 18 and breadth is also 18. So what does that mean? The rectangle is basically a square. So for a maximum area, the rectangle has to be a square. So simple. Look at these questions again and we'll do next one. Right? We'll do the next. Achha, we have to solve the like using first derivative, right? So we'll take a question where we'll use the first derivative method. So let's say we have next. 1 second. Let's say we have here f of x is equals to x upon x square plus 1. And we have to find value of x, maximum and minimum value of x. Got it? So what we'll do here, we'll find f dash of x, find f max. So we'll find f dash of x. F dash of x we have to use u upon v rule. So v derivative of u 1 plus u derivative of v upon v square means x square plus 1 the whole square. So after simplification I will get x square plus 1 plus 2x square upon x square plus 1 the whole square. That means 3x square plus 1 upon x square plus 1 the whole square to make it 0. Now, when cross multiply, we will get 3x square plus 1 equals to 0. That means x square will be equal to minus 1 by 3. Now, please note how my x square can be equal to minus 1 by 3. A square quantity cannot ever be equal to minus 1 by 3. That means this is not possible. And that clearly means function has no maxima. Function has no maximum value. What does that mean? The function has no maximum value. Got it? The function has no maximum value. Simple. Got it? Now let's suppose say next question. F of x equals to x log x upon x. So log x upon x. Same. Find f max and f min. Chalo. So we'll first find f dash of x. Again we will use the u upon v rule. So what is u upon v rule? V derivative of u log x का derivative minus u log x into derivative of v upon v squared. I guess here we made a mistake, right? Yes, here it should be minus. Guys, we made a mistake here. It should be minus. Okay, let's complete this question first. It is u upon v rule, na? You also didn't point it out. So now it will be x square minus 2x square. So 1 minus x square. Yeah. So 1 minus x square equal to 0. That means 1 minus x square equals to 0. That means x equals to 1 ya to minus 1. Now, how will I check whether we have maximum or minimum at 1 or minus 1? So see, we'll use the first derivative. It says that these are the stationary points. These are the stationary points. So stationary points may, what do? We see if it is positive to negative, then it is maxima. Negative to positive, then it is minima. So we'll see the sign of dy by dx. So we'll use wavy curve. See how it will end. This is wavy curve for f dash of x. Please remember. This is wavy curve for f dash of x. This is f dash of x, not f of x. So we'll get the sign of f dash of x. So positive, negative, positive. Where it is positive, where it is negative, where it is positive. So we see. And minus 1. Minus 1 by f dash is 0 because it is a root. We got it. So before minus 1 it is positive. After minus 1 it is negative. So at minus 1 dy by dx goes from positive to negative, implies positive to negative. Maximum at x equal to minus 1. So what will be the f max? F max will be equal to f of minus 1. Okay. So f max is minus half. Now let's see what happens at x. So at x equals to 1, dy by dx goes from before it was negative and after that it became positive. That means minima implies minima at x equals to 1. So obviously we have to find only f max. So we don't need to find the f min. But just I wanted to say how do we use the first derivative test? We use the wavy curve method. You can also cross check using the second derivative test. If you cross check using second derivative test, then it will be like verified. Yeah, both of the test works. Got it? So let's look at this. Yeah. So here x and x will get cancelled. We will get 1 minus log x upon x square. We'll again use first derivative test equals to 0. So what does this mean? This means 1 minus log x is equals to 0. So that means log x is equals to 1. That means x equals to e. Right? So what we'll do, we'll again use wavy curve. As we have only one stationary point, E. So what does wavy curve say? Positive, make a wave, negative. This is positive, this is negative. So what does this mean? That at x equal to E, at x equal to E. Let's see. dy over dx, before x equal to D was negative. Then it got positive. That means minimum at x equals to E. Minimum at x equal to E. And if it is minimum, then what will be f min? F min will be f of E, which is log of E upon E. And log E is 1. So 1 upon E is the minimum. And we can say, since there is only one stationary point, the one stationary point could be either maxima or minima. But so we got minima here. That means there is no other stationary point for maxima to exist. Because I don't have time. So let us, in the time, revise the questions or revise today's work. What we did here, we started with increasing and decreasing functions. We started with increasing and decreasing functions. So if you have any doubts, please you can ask me. I will change the slides in 30 seconds so you can go through what we have done here. Also, I will keep talking, so don't mind me. Increasing function, the what we learned, dy by dx should be greater than 0. Decreasing function, what do we learn? Dy by dx less than c. Or how do we calculate it? That was the mathematics. As x increases, y means f of x also increases. Increasing and decreasing based upon f of x. As x increases, f of x decreases. So if this is the case, increasing function. If this is the case, decreasing function. And monotonic function is used for both. A monotonic function can be either increasing or decreasing. Next, we saw the questions here. What are the types of questions? Very simple. Increasing means just find f dash of x. If it is greater than 0, then increasing, less than 0, then decreasing. Simple. No simple questions apart from this. This is the very easy questions on monotonicity. After that, this is the ulta question. It is given that increasing, we have to find x. So how do we find x? Increasing is greater than 0, and using wavy curve, we can simply get it. Next, we saw maxima and minima. What is maxima and what is minima? I hope you got it. What is maxima and what is minima? Maxima means the point will be on top apart from the neighborhood. Neighborhood means on the left, on the right of that point. Minima means that point will be the bottomest on the neighborhood. Right? What are stationary points? The points when f dash of c equals to 0. And there will be either a maxima or minima at stationary point. So we saw this from graph, the second derivative test. F dash of c equals to 0 and f double dash less than 0 means maxima. Oh, here it should be greater than. Here it should be greater than. F dash of x equal to 0 and f double dash greater than 0 means minima. What is the first derivative test? Maxima के लिए dy by dx changes from positive to negative. So we'll get maximum. And minima के लिए dy by dx changes from negative to positive. Then we'll get minima. So we now, इसके बाद we saw the questions. What we saw the questions? How to do with second derivative test, how to do with first derivative test, and application questions, like real life problems. So from this, we can also do this by first derivative test. Got it? So if we plot this equation in the wavy curve, you will see -2, 4. Positive, negative, positive. So from 2, it is positive to negative. So 2 पे क्या आएगा? 2 पे will get maxima. And at 4, it is negative to positive. So 4 पे क्या आएगा? Minima. So that what we got by using second derivative test. X equal to 2 is a point of maxima and x equal to 4 is the point of minima. So first derivative test is more effective and more easy, you can say speedy test to check maxima and minimum. So obviously, if in MCQ we get in JEE mains, we will always use the first derivative test. We will never use second derivative test. Second derivative test में calculations भी बढ़ जाता है and it is very tedious. So you can saw your first derivative में एक diagram बनाते ही using wavy curve only we got a answer. Got it? So let's end the section here. I hope to see happy Ganesh Chaturthi to all of you. I hope you enjoy your vacations and Ganesh Chaturthi especially. Chalo, we'll end here. Bye bye. Take care, everyone.